Hello everyone and welcome to Handmade, here on the show where we code a complete game live on Twitch. No libraries, no engine. It's just, the old-fashioned elbow grease style of game development right before your very eyes. Of course, we've already kind of gotten past a lot of the stuff that's the elbow grease. We've already sort of done a lot of the work on like rendering and entity storage and all that sort of stuff. We're kind of getting to the point where this might start to be some semblance of an engine. We're at the point now where we're even thinking about maybe in a week or two here starting optimizations on the renderer. So, it's getting down to it. I think originally I had ballparked that we'd spend about 200 days, which is roughly 200 hours. So that breaks down to 5 weeks of programming time, basically, 5 weeks of full-time programming time. And 5 weeks of programming time is like nothing, right? Like 5 weeks of programming time is nothing. And so I was thinking, well, 5 weeks to make an engine, sure, why not, right? Seems a little ambitious, but it should work. And so far, it looks like we might actually make that. We're only halfway through our time budget for stuff that I was thinking, we'd want to do, and there's just not a lot of stuff left to go. We've got, some renderer work to do, probably do 20, 30 more days of render stuff, I'm guessing, something like this. And then we're back to just kind of a little bit of list of features that really aren't, I don't think, that heavyweight. There's stuff like just, doing a real collision detector and, maybe doing some debug code, that sort of stuff. But there really just wasn't that much on our list. So I don't know. I'm feeling pretty good about it. I think the 200-400 breakdown is actually not going to be too far off, potentially, which is 200 hours of coding on the engine and 400 hours of coding on the game, which roughly breaks down again to something like 5 weeks of programming time to build the engine, and then something like 10 weeks to build the game, right? So it's like a 3-month, 4-month kind of a thing. So we'll see. We don't know where we're going to be, but that's roughly the thinking, and it seems like it's going okay so far. If you would like to follow along at home today, today is day 106, so go ahead. If you've pre-ordered the source code, you should have a zip file. Unzip 105's source code, day 105 source code from the zip file, and that is what you want to start with right here, right now, so that you can code along with me, and it'll be like, it's like riding a tandem bike. You know what I'm saying? But you're on the back, bro. I'm in the front. All right, so we left off. Don't ask me why this happened. Yesterday in the Q&A, people were asking if we could reflect actual images instead of checkerboards, and I'm assuming there were people who weren't here when we implemented this stuff and explained how these were just images, and we put checkerboards in them explicitly for the purpose of having something we could see the lines in. And so we ended up blitting some ground into our bottom bitmap here, and that's why our bitmap is no longer reflecting a red checkerboard. It's reflecting this patch of ground that we grabbed. But that's just totally, that was not at all what we were supposed to be doing. That's just some stuff that people asked in the Q&A. And so what we were supposed to be doing, I think I might actually turn off that little, that stuff for right now. Actually, I think I might just go in here real quickly, just while we're talking about it, and turn off the coordinate system test stuff that we still have in there. So in here, I'm just going to go ahead and put that back to an if 0, just to get that out of the way there for us. And so now we're back to just having the actual game graphics, which is what we wanted. And today, what I had said that I want to do, and what I think that we probably should do, is to start getting our Z situation straightened out. Because that's kind of the whole reason that we dove into the renderers. We were kind of like, well, you know what? We have to start nailing down our Z, because that was one of the last things in our engine architecture that wasn't quite there. So what I want to do now is I want to start changing over. I think what I want to do is just flat out change over the rendering so that we're going through the coordinate system draw instead of the main draw. Now this would probably tank our frame rate quite a bit, but I don't really care about that right now, because like I said, we're going to optimize the renderer. So I don't care about that, but what I'd like to do is get it so that we're drawing the world through something that can scale it. And the reason that I'd like to do that is because once we can scale the world, we can kind of see how things stack up on each other and zoom and that sort of stuff. And so I want to see how bad it would be if we just started going through the coordinate system drawing call to draw everything. So let's go ahead and try that out, right? So if you take a look in Handmade render group, right, we have our draw rectangle slowly call. There's really no reason we can't call the draw rectangle slowly call with our bitmaps, right? Because we've got, essentially what we have here is our push buffer processing stuff is, it's basically like a stream processor, right? It reads out of the stream, it sees what's coming into the stream, and it translates those into actual code. It basically says, I'm reading this buffer and I'm going to do operations on it. So it's pretty free for us to just say, okay, we used to render a bitmap like this, but maybe, we actually want to render a bitmap in a different way, and there's nothing wrong with that, right? We can just go ahead and call a different function here, draw rectangle slowly, for example. We can go ahead and call that instead. So we can pass the output target, and then we just have to fabricate these other things that we actually want to have, right? So we know what some of the stuff is, right? We know what the bitmap is that we're doing. We know that we don't have a normal map or any of these other maps at all, right? Pixels to meters, I believe, is something that we're just sort of computing here, right? Because we didn't actually have that. So there we go. Although what I might do is let's just get that out into a variable so it's not getting spammed everywhere. Pixels to meters, there we go. And I'm going to go ahead and put that up at the top. There we are. So pixels to meters, there we go. Pixels to meters is now pre-computed, which is what I wanted, and that's just the inverse of our meters to pixels. And so now we've got mostly everything we need. We just need the placement of this thing, right? We just need to know where it's going to be. Now the origin we've got, it's that PX PY bit. So if I just pull that outside, in fact these can all be outside, if I just use that P, that XY there would tell me, and I know that the X-axis and the Y-axis are just the standard axes, right? I know exactly what those are for now. And then the color value obviously is something that's been passed in. And so if I want to, pixels to meters, there we go. I can now, in theory, I think, call through the slow path and go, ooh, or not. That was awesome. So just realize something. This has to be the entire size of the thing in pixels, which I just remembered. So if this is the entire size of the thing in pixels, that will draw everything as 1 pixel, and you can actually see the little pixel dots in there. We could make it a little bit better by making them a little larger. There you go. You can see everybody's little tiny... Oh, that is funny. Okay. Sometimes the bugs are more fun, than sometimes the bugs are the most fun thing, I guess is what I would say. All right. Sorry, I lost my train of thought there. What I was trying to say was that the x-axis and the y-axis, currently we pass those in with the entirety of the scale of the thing that we're drawing baked in. And so what that means is we would have to use the bitmap itself to sort of get that width and that height that we need, right? That we need to specify. So I believe we can just pass that along. I don't think we have to do anything special for that. What's the problem here? Sorry, there we go. So I'm pretty sure that's actually not really a big deal. There you go. And you can see that our frame rate is super slow now, right? That can just give you some idea of how expensive that calculation really is. It's fairly expensive, right? Because right now, that routine is so totally unoptimized. It's just, yeah, it's pretty rough. But at the same time, what is kind of interesting about it is, even so, looking at this currently, this is still not that bad. Like, for how ridiculous that function is with what it's doing right now in terms of how inefficient it is, this is actually pretty good. And again, this is why I say I'm kind of surprised, and this is a 5-year-old computer, right? I'm kind of surprised by how fast it really is without having to do any real work. It's kind of crazy. So at the end of the day, this, I think, bodes pretty well for us in terms of our optimization, because really, like, getting it from here to be something that's real-time, just isn't, I don't think, that bad. And you have to remember also, we're doing some really stupid stuff right now, even if you don't even talk about how unoptimized the code is, there's also another part to it, which is that right now we're not even like bothering to pre-clip our sprites. So for example, this head is actually running over all the pixels that are in this entire giant rectangle, right? Because we're not even clipping our sprites to just be the region that's actually filled with valid pixel data, right? So we could actually improve things quite a bit probably by fixing that as well. But at the moment, like I said, not a super concern to me because I'm really only concerned about what things look like, not how fast they run. I'm fairly confident that we'll be fine with that. So what I like about this now is now that we're going through this path, what that means for us is we'll be able to scale things up and down, which I think is a pretty important thing for us to do, actually. I feel like that's good. As I spill water all over myself. I feel like the scaling is a good thing, but I do have one sort of one thing that I'm not entirely certain about in terms of how we want to deal with the scaling, or whether we even want the scaling or not. And what that is I'm not currently certain when I do the scaling. I don't actually know whether I want to scale each individual sprite all the time, or whether instead I would rather do it so that we draw into a buffer and then scale that, right? And just to sort of give a little bit of a perspective on how that's working, this is what I'm sort of thinking through. So the thing that I'm not sure about is, let's take, for example, the ground tiles, right? So the way that we're doing the ground tiles right now is we essentially have ground tiles that we fill in with ground data, right? And by the way, when I'm saying ground tiles, I mean ground like floor, right? Not like beef. So we're not talking about ground beef here. When we say ground beef tiles, that would be a very different thing. We're talking about things that are on like the ground. Okay, so when we do these, you can imagine that if we wanted to make it appear like we had multiple height levels, right? So looking from the side, we're doing this. If we wanted to make it appear like the things that were higher, closer to the camera, right? Like here's the camera looking down. Things that are closer to the camera, if we wanted to make them appear as if they were scaled upward, there's two ways we could do that. One is that we could render the ground tiles into a buffer first, that is basically the ground buffer, right? And then scale that up, right? The other way we could do it is scale each individual ground tile to make just a bigger set of ground tiles, right? And there's good and bad aspects of doing these two things. First of all, as you've seen, scaling is more expensive. Like something that allows scaling is a little more expensive than something that just does a direct rectangle copy. So one reason that we might want to go with this method is for speed. Because if we just did a blitz directly into this buffer and then did one blit that scales up, we might be able to make things faster. However, on the other hand, we have to remember that it would incur one whole extra copy from from one buffer to the other, right? Which, if we were able to make this version fairly efficient, might actually end up being a lose, right? And especially since memory bandwidth tends to be a real big problem and maybe computation is not such a big deal in certain circumstances, we don't really know where that trade-off lies. And so the other thing that's, I think, a little bit better about going this way with it is we don't incur any problems with scope. So if we were to, say, scale it down, so let's say we were making a small thing. So here's the screen, right? And there's a floor that's off in the distance that we're trying to render. This becomes problematic if we actually wanted it to fill the whole screen, right? And the reason it becomes problematic is because if we wanted to fill the whole screen like so, right, that would mean that our starting buffer would have to be huge. It would have to be like 9 times the size of the screen in order to scale down to something like I've drawn here, right? Because it has to be this big, right? It has to be the size of the screen when scaled down. And so if it was, if this is actually how big a screen size thing is, then that means that you'd have to do something way, way bigger than the screen as the original buffer to shrink down. So I think it argues for not doing that sort of post-pass kind of thing. It argues for actually rendering things the size that they're supposed to be directly and not going into an intermediate buffer. Now, that said, I do think we may need to do some stuff with intermediate buffering, and I'll talk about what that is in a second here. So let's say that we're going to allow some number of ground levels, right? So let's say that we do something, right, that looks like, I don't know, that looks like this. And the way that this works is, in fact, I'm gonna draw it a little bit differently. So let's say that we do something that looks like this. And the way that this works is, this is the level that we're actually looking at, right? So this is what we're looking at. And this is the next level down, right? And this is the next level down from that. And so what we want to do here, right, is we want some way of, as we move, as the character moves, like if there's a stairwell in here, and they move up the stairwell, right? And remember, we're looking down from the top on this. If they move upwards, what we want to do is we want to make it so that, oh, I guess I drew that in the wrong place. Sorry. If they move upwards, so that this will become the new level that we're looking at, right? So we're going to move our camera view up. We need some way of having that new level come in, right? So we want to do something there like an alpha fade or something like this, where we can actually fade it in on top of the underlying geometry, right? And maybe, you know what, I think instead of trying to explain to you what the problems are with doing that, I think maybe I'll just implement it. We can just implement it right now, the stupid way, and I can show you why the stupid way is a problem before we talk about ways to fix the stupid way. So let's do that. Really, I do need to, at some point, remember to ask Yangshin to draw us a stairwell, so I can just put a stairwell in here, instead of having to constantly pretend that we have a stairwell, which we currently don't have. So anyway, what I'm going to do for temporary purposes is I would like to make it so that we have, instead of moving the hero in Y with the W and S keys, or you know what I'll do? I'll just make it so that when you hit the space bar, instead of that being a jump, which we don't actually need, what I might do is, oh wait, you know what? I don't even need any of that. I'll just use the arrow keys, because we've got those bound as well. I'll just use the arrow keys to basically give me a way to move the hero in Z, just up and down, right? Or not even the hero, just the camera even, right? I don't even care about the hero where the hero is. I just want to be able to move the camera up and down so that we can see what happens when it zooms kind of in and out, if that makes sense. So what I'm going to do here is we have that sort of action button thing, right? We've got these action buttons. And what I'm going to do right now is I'm just going to kind of take out that code that was sort of when we were in there testing sort of ability to fire things and that sort of stuff. And I'm going to go ahead and make some code here that just looks at whether that initial button is up or down. And I'm just going to make a simple little thing that allows me to move the camera up and down. Because we've got a camera, we've got the camera P, right? And I don't even remember exactly how we're doing it, but I think right now we actually just have the camera track the player, right? But I don't actually remember what we really did for that. It looks like that's not it. It looks like that's handled entirely in the sim region. So let's take a look there. Sim region, CPP. Yeah, and so basically the camera, we just got an entity that the camera follows. And so all I'm going to do is, when we do the drawing here, I'm just going to introduce a synthetic offset to the Z value that I can control, so I can move things up and down, basically. And that'll be, that'll be it. So, like right here, when we do base P get entity ground point, I'm just going to add in a Z offset, which basically, literally it's just going to be for our testing how the zooming works, right? So we'll go ahead and make that just some temporary variable that's in here. So in game state, there we go, got z offset. And I would like to make that controllable by these keys. So I'm just going to go ahead and do something like z offset plus equals, I don't even remember what our time value is here. I think it's dt for frame. Or did we actually bake that out into a dt? We don't. It's still right here. Let's go ahead and grab that. And so I'm just going to take whatever the rate is of the zoom, and I'm going to multiply it by however many seconds have elapsed. And so we're just going to put those in here, like so. And in fact, you know what I might do? I might just make it work like this, right? So we'll do this, zoom rate, and we could set the zoom rate for in and out. And I don't really know, let's say we go up a meter per second, and then when it ends, when we're doing action down, we'll go down a meter per second, something like this. And I feel like that should allow me to, oh, what happened here? Oh, is this, is this because I added, oh, that's because I added something again. Sorry, I'm a little out of it today. I forget every time that if you add something to game state, you have to restart because we don't handle that in our live updating. All right, so in theory, we should have something that goes a little too quickly there, but now we've got something that zooms us in and out, right? And so we've got two things that we want to do. One is I want to change the scale of these things as we zoom in and out, obviously. But the other one is then I want to talk about that alpha situation, since that was kind of what I got into on the Blackboard, right? So as we zoom these things in and out, we need to start to think about this. I want to make this rate a little slower there. Let's go ahead and make that slower. Although, you know what? That might just be because our coefficient is too huge, right? If you remember, we never really did. We said we'd postpone it till today, but we never, because we never quite got to the get entity basis p stuff, right? Where is that? Get entity, get render entity basis. This thing is still translating the meters to pixels. This factor here we have not really thought through at all. And so really one meter per second is probably fine. Actually, now that I think about it, it's probably this value that needs to be smaller. And we'll have to think about what we actually want that value to be. That's the value that controls how much sort of scaling we do based on Z motion. And so I feel like that's probably going to be something closer to what we want for the time being, right? So as you can see, the positions of the things are being scaled. The sizes of the things, however, are not being scaled. And that's pretty straightforward. Really what we've done here is we've created our zfudge value says how much we're going to scale the positions of things, but we've never scaled the size. And so that's actually pretty easy for us to handle, you know, when we sort of go through this after we sort of figure out exactly what we want to do with these tests, and then we kind of come back through it. We can do it potentially in a little more clean way, but for the moment it's actually pretty easy. We just have a scale that we could have here, since we know that we're always scaling uniformly for the zooming, basically this zfudge is just our scale value. So if we were to scale the size of the sprites by that same thing, the same thing that we're scaling the positions by, it would line up, right? So this zfudge here, I'm just going to go ahead and say that when we do, oh, whoops, I put that in the wrong place. When we do get render entity basis, what we really want to do is have that return us a scale as well as a placement, right? So there's like an entity basis p or something, right? Something like this here, or result, which is going to have the position and the scale, right? And that's really all I wanted to do. So I'm going to return that instead here. Here we go. There's our result. So what we want to do is put the center in there, and then put the scale in there, and the scale is just the zfudge. There we go. So then when I get render entity basis P, that's actually going to be the entity basis P result. There we go. And that's the, I don't know, we'll call that basis or something. And so then when I do my drawing, we have it's basis.p is the actual place that I'm drawing that at, right? And I need to fix the other one here too, right? Well, actually, I don't even have to. That's just that. Although technically we should fix this one for scaling as well. So we'll do that in a second. Anyway, so you can see that nothing's changed when I've done that. Everything's the same. But now if I actually take that scale value and say, well, now we kind of know these are our two basis vectors, right? Here's x and y. What I want to do is go ahead and take that scale, right? And I just want to multiply the width and the height so that it changes with the scale as well, right? And now you can kind of see as I shrink the things down, we're actually getting a real shrinking instead of a fake shrinking there, right? Like so. Now, we still have, obviously, more stuff we got to do to make that work right, and also our ground chunks are not playing along. But you can see how that's kind of putting to good use the code that we wrote over the past few weeks, where we can do our scaling now. It makes it nice so that our trees, our trees have kind of a nice little scaling effect. I can see, however, that there is a bug. We thought that there probably was one. We were going to go through it with a fine-tooth comb. You can see that we're getting a problem with sort of when we zoom in. You can see that the actual popping at the very top of that tree, right? And I don't actually know. That may not actually be a bug. That may just be the way the sprite is constructed. One of the things that I talked about but we haven't quite covered yet was that we always need one pixel of emptiness around everything in order to make it work properly, and we'll talk a little bit more about why that needs to be later on, but I just wanted to call that to your attention. I don't know if you can see that. It might be too hard for you to see because of the way video compression is or whatever, but it's there. All right, so why our ground isn't scaling, I suspect is because we're not actually giving it a proper z value, would be my thought. And so I think, right, our z offset, which we kind of added in here, we need to add that to the ground chunks as well when we render them. Otherwise, they're not going to scale, right? And so if we go into the ground buffers when we're actually doing that thing and we do our push bitmap, we do the push bitmap with the delta, we need to be able to put in that camera offset there as well, right? And so now I think with that in there, we should get them scaling. Although for some reason, no, we don't. Oh, because that's actually not the way that we have our basis stuff working. This was the thing we talked about yesterday. So we said that our z-fudge is only based on the base p, never on the offset p. I don't know if you guys remember that, right? There is this whole situation with, because we're in 2D, we talked about this literally yesterday, because we're in 2D, we wanted to make it so that the position and scale of things would change, but they wouldn't lean if they're stacked on top of each other. So if you basically have, like, imagine a snowman made of three pieces, right? His ground point will scale, his things will scale, but the placement of these guys on top of him will not change. So he remains perfectly vertical, even though the perspective would have potentially have actually made him look like that, right? We decided to keep that sort of straight up and down scaling. And so what that means is I can't pass it here. I have to actually go ahead and make it be in the basis itself, which is, again, not a particularly big deal. It just means that we have to do our basis push here, right? So basically, every time we do one of these, we've got to do that push. Excuse me. The basis is going to have a placement, which is, I guess, the delta, now that I think about it. There really isn't any offset for this thing. So the offset for the bitmap is actually always going to be 0. And our basis is going to capture all of the information about where we want it placed. That's actually how the renderer is supposed to work at the moment, right? And so this p value is actually supposed to be the delta, right? So that's going to be delta plus, again, that z offset. go. Oops. Guess I need to pass a non-offset here. There we go. And now we're close. We're close, but we've still got something odd happening, which is that our scaling of positions doesn't seem to quite properly line up, right? You can kind of see as we scale, our stuff is not where I would have expected it to be, right? As we zoom in, things scale kind of counter to each other. And you can see this happening with everybody, right? They're not scaling about the right coordinates. And so we need to kind of go take a look at how we're doing our bitmap alignment and stuff like that to figure out what's going on there, right? And I suspect that part of that has to do with the fact that we translate, we do translation and alignment in this, you know, kind of ad hoc way that happens at the head of the rendering stuff. So let's go take a look at that and get that straightened out. This is good. I'm really glad we're doing this. This is basically like, this is one of those weeks that I'm just happy about everything because we're taking a bunch of stuff that we haven't done properly and haven't thought about very carefully, and we're, you know, fixing it basically. So, okay. So let's go in and take a look at how our coordinate system stuff works in terms of when that scaling occurs and who it is applied to, just so we can figure out exactly why it's not quite doing what we think it should do. And just again, I hopefully people can see that. In fact, you know what I'll do right now? I'll turn off the ground chunks entirely because they're not actually necessary. And the other thing I could do too is let me quickly just fix those rectangles as well, because those need to be changed. So the rectangles need to be scaled, obviously, so we can get the basis P here, like so, and that's going to be applying the scale to the dimension of the rectangle, right? Like that. Oops. There we go. Okay. So as you can see, like when we scale stuff, in fact, you know what, maybe I'll just even turn off these for a second so we don't have to fix everything at once. I just want you to be able to focus on the stuff that I'm talking about. So you can see this scaling here, right, as we scale. And what's particularly strange about this, right, as we do it, is you can kind of see that for some reason we get a lateral motion on the characters, right? You can see that, like, as I move around here, everything's still the same as it was for the most part. But when I do the scaling, I move to the side, right? It doesn't make any sense, right? Like that should not, that's visually totally nonsensical, right? Oh, you know what's kind of cool about this? This is kind of awesome. I totally forgot, but now that we have the ability to scale out, we can see our sim region pulling stuff in from the worlds as we move around, right? These are the things that are in the simulation set. Remember? And so that's kind of cool, right? That's pretty neat. All right. Anyway, sorry, I got a little ahead of ourselves there. So what I want to do is I want to go figure out why we're getting that lateral translation, and it's hard to say who is at fault there because, you know, we don't really know who's scaling properly. It might be probably the case is no one's scaling properly, and they're just kind of the trees are at a particular Z level and the guy's at another Z level and whatever, and so it ends up looking a particular way. But really, I think what's, you know, the scale is not happening in sort of a coherent way. We want the scale to scale around the center of the screen, and neither of these two things seems to be scaling around the center of the screen to me, I guess is the way I would say it. And so what I want to get to is when we zoom in and out like this, I would like to see the center of the screen be the point that things shrink around, and everything should appear to be stable relative to each other, just scaling. So off we go. Okay, hopefully that all makes sense. Nothing particularly weird going on there. So let's take a look. when we are doing our scaling, we're already centering everything about the screen center, right? Because we're starting at the screen center and we're moving by whatever the entity xy is. And then there's the offset xy, which is obviously a constant that's applied on top of that. I'm interested to know also what happens if we turn that off, by the way. Right? Yeah, so that's actually our problem as well, if you take a look at it in terms of why these things are sliding relative to each other, is that offset right there. So what were we trying to capture with that? The offset xy, it's kind of a little bit odd, because my understanding was that the offset xy should have been the thing that the entity that was allowing things like okay, I see. So the offset xy is the thing that's supposed to allow different parts of, say, the hero to be at different levels, right? So for example, if his head was supposed to be higher than his body, that was the thing that we would use for that. But what I forgot is actually our current state of the hero is that he's actually all on the same level. These sprites are not clipped yet, so they're not actually offset from that ground point. So the reason that doesn't actually do anything in terms of offsetting is because the actual values of the sprite were all the same, right? So I can turn it off and he still looks okay. But if I go ahead and rebuild this here, you can see that that actually does change things. I believe that's because the offset xy of the entity basis, excuse me, is still getting set, right? It's actually still a value. Let's take a look here. Who is setting that value? Now that I think about it, who's setting that offset? So when we render like the head, these offsets are all set to 0. So I guess the only thing that we're actually using this offset for right now is the bitmap alignment. That's it, right? The bitmap alignment's actually the only thing that's going in there. And so since that bitmap alignment is in there, I'm trying to think of why. Okay. So that bitmap alignment, here's what's going on. This actually makes sense. If I wasn't having such a slow day, I don't think this would be really that big of a deal, but here you go. So what's happening here is that we've got, a bitmap, and we've got a point that we're using to place it, and we have the offset that says where that is, right? And so actually the way that this works, we actually do it in the reverse order if you think about it. What we're doing is we've kind of got a displacement that says, well, I want to say that the guy is here. I want to say the tree is here. But the bitmap is actually a rectangle, so I need to move to a new place so that when I draw it, right, it will still line up. You know what I'm saying? And so this value here actually definitely does need to be multiplied by that z fudge value. So this definitely wants to be in here because as the dimensions of this change, we would move less far out, right? If this rectangle gets twice as large, this displacement has to get twice as large, and so on. So this is the thing here. Not using the offset's z value is correct because we wanted to keep things straight up and down like the snowman example. But we do need to scale the offset because as we change the size of the bitmap, that offset's going to differ. So I believe that that was just a mistake that we made that we didn't want to make. And hey, now you can actually see when we scale, it looks properly, right? It looks like what we expect. And I can go ahead and turn that ground back on now. Let's take a look where that was. Hello, Mr. Ground. Push bitmap. There we are. So we can turn that ground back on, and there's the ground again. And again, this is kind of fun I don't know, this is one of those things, I don't know, it's just kind of fun. If you take a look, you can see now sort of our world stuff happening. As you kind of move in, you can see it filling the ground chunks as necessary and that sort of stuff, which is kind of cool, right? That's like, I don't know. It's just kind of nice to be able to zoom out so you can kind of see what's going on in the world. So when we zoom in here, right, I think everything is now relatively stable. Looks pretty good to me. Yeah. I feel like we maybe don't... Oh! That's kind of hilarious. So our jump is still active, and as you can see, our hero gets bigger as he jumps, which is pretty hilarious. Yeah. That's pretty hilarious. I feel like we want to bake that jump probably into some kind of an offset. Although, I don't know, it's kind of funny to see that happen. I don't know how we feel about that. Maybe we do want him to get bigger. That's pretty hysterical, dude. Yeah, as he jumps, he gets large. That's funny. So yeah. So back to what I was saying originally. It's been a pretty scatterbrained day here. I apologize for being so out of it. So basically, what I wanted to show was some problems with alpha fading, right? We talked about this and kind of, cursorily at the beginning of the episode, and I wanted to say, well, what happens if we need to start having a level above this one that's going to fade in and out? So what I'm going to do is I'm just going to take the level that we have right now, and I'm going to show you what happens if we do the stupid way of doing alpha, which is to just draw the sprites, and you see this, actually, this drives me nuts. You see this in indie games sometimes, and I'm always like, oh no, don't do that. When you have a situation where you're trying to fade out something en masse, sometimes what people will do is they'll actually just set the alpha value of the various components, right? And so you can imagine what that would look like here if we went into the renderer, right? And let's say that inside this entity basis P thing, right, we had some kind of a thing. Oops, sorry, that's the basis P result. That's not what I actually wanted. I meant inside the render basis thing. Suppose we had, we were to introduce something like an alpha fade value, right? Or maybe even do it in a slightly different way. Maybe we just have a thing where we can sort of, as we're pushing things, we can set kind of a global alpha value or something like that, right? And so at the outset, that global alpha value is going to be 1, right? And I don't actually remember right here. There we go. So that global, we've got 15 minutes on the bonus clock, right? So I'm going to go ahead and take those. So our global alpha value is 1. And then every time we get an alpha push on one of these bitmaps, I'm just going to take the alpha and I'm going to multiply it. I'm going to go ahead and multiply it by the global alpha, right? So I'm just going to flat out have this global modulation that I can do to make the alpha value be there, right? And so now what I'll do is I'll just say, oh, okay, as I zoom in and out, I want to be able to make that sort of global alpha. I'm going to set that to be something proportional to the z offset, right? So when we do the render group, I'm just going to say render group global alpha. That's going to be equal to game state z offset. And I'll clamp it from 0 to 1, like so. And I want to basically do, like, let's say 1 minus the z offset. So it starts out, everything's full alpha, and then as I change it, I want it to differ. And so here's what happens as I zoom in, right? Do you see what's happening there? Now, what I'd like you to look at most importantly, right, is take a look, for example, I'll put the hero in a particular position, maybe right about there, okay? And as I zoom in on him, watch what happens as he disappears, okay? You can see through his sprite now into the background. And same as with like the trees and stuff. And so instead of a fading out effect, you get sort of an effect as if everything turns to mist. But it doesn't actually feel like I'm fading out this layer. It feels like everything's turning into like a weird ghost version of itself, right? Now, maybe that's fine if that's what you're going for, but usually that just looks amateur hour, especially if there's stuff like, you shouldn't be seeing stuff perhaps behind some of these things. It might be that the art there wasn't set up for what that's supposed to show or whatever, and it's just not good, right? So in order to fix this particular scenario, right, we want to be a little more conscientious with how we do our z-layer stacking. I'm guessing that probably what we will want to do is do an off-screen composite first of each slice of our world that might be fading, right? And so essentially, if we go back to this diagram, what I probably want to do is have a render buffer that's going to render that top part that might be fading out or fading in, right? This part. So, if you actually think about maybe how we bucket this, let me go ahead and say something like this. There's a render buffer A that will take whatever's in here. Then there's a render buffer B that will take everything that's in here. And then a render buffer C that will take everything that's in here, which is things that are fading in. Now, A and C are actually mutually exclusive because either we're going up or we're going down. And so we don't need both the fade in and the fade out layers, right? Because this layer is fading out if we're going up, and this layer is fading in. And same if we were going down, we'd have the opposite. This one would be fading in and this would be fading out. So we only really need two buffers, right? At any given time. We need the main buffer and then one of the fade buffers, right? Whichever one we're in between, we need to run there. But what I think I'd like to do is actually have those two buffers so that we can do the fade in and the fade out properly, right? And so I don't actually remember where we left it. If I turn off our ground buffers for a second, let me see where we're at here. If I turn off the ground buffers for a second, and I just have this. If I want to get a second layer in here, I feel like we have the ability to do that. I feel like if I switch between these, I feel like I should probably make this official at some point, huh? There we go. If we do that, that gives us the ability to have multiple world layers, right? If I remember correctly. Let's see if that's actually true. I don't know if it is. So here's my guy. So yeah, if I zoom, wow, those things are really high up there though. My goodness. What exactly is the Z value on those things? Hold on a second. That would suggest that our Z multiplying is really far off. So that's something we're going to have to take a look at in a second. That's, again, this coefficient here, which is controlling how much of that sort of Z happens, right? So that looks a little more sane there, right? Yeah. So part of the problem, too, of course, when we're looking at this, is we don't really have much... oh, hey, and there's our secret stairwell. Forgot about that. So we can actually go up to the next level. We got to turn off the ground buffer rendering as well, because the ground buffers take a long time to render now since they're going through the scaling path as well, which we really probably don't want to do. But yeah, so things are a little wonky now. I'm going to go ahead and turn the ground buffers off entirely. Let's see, ground buffers. And really, I just don't want to spend the time. I don't want to spend the computational cost to generate them, is basically what it boils down to. Because until we do, again, the renderer optimization, I really just don't want them taking up any time at all, really. So I'm just going to turn off our ground buffers entirely, like so, right? And then, we should be good to go. So now, when we're rendering this stuff, again, it's a little bit weird for me to work with, because it's still got this notion, right, of it's still got this weird notion of Y displacement for Z as well as Z displacement for Z, which I don't actually know if that's such a good idea. It's a little bit, it's just been very confusing for me as someone who comes from a place where they normally only use 3D coordinates, it's kind of hard to always wrap your head around what's happening there, right? And so like you can kind of see what's going on here with the with me playing with these z values. You can basically see that that value changes how spread out our stuff is based on the z difference from wherever the player is, right? Now there's some stuff that we probably want to fix about that, and maybe now is as good a time as any to talk about it. But I'm just kind of playing around with this here because I want to see sort of how it feels, right? And so it's still that's just very strange. So I feel like this wants to be a different value, and I think we may want to put in something which does a little bit more of a real perspective transform there. So let's think about this. How much time I got left? I got about 5 minutes left. All right. So all I'm going to do right now is I'm going to go ahead and take that alpha value thing out, right? The global alpha. I'm going to go ahead and set that to 0, like so. And I want to take a little look at this, right? And I'm trying to decide what I want to do in terms of the z offsetting to y, right? Because the z offsetting to y, if you remember, this is what does that, right? This term right here is what does that. So if you could imagine, if we turned that off, then we would have only z offsets, right? So this is what the world looks like with z just being treated as z, no y at all. And so, when we come, if we come in and out of that, or if I walk my guy up the secret phantom stairwell, you can kind of see what that ends up looking like in terms of just raw z offset values. And it kind of feels to me like it's another situation where really, because of the way the 2D, 3D stuff interacts, it's almost like we want there to be scaling for the guy, for the world, based solely on like the Z layer that you're in, but not on fine-grained Z motion that happens like inside that frame, right? So if you're jumping or whatever, I don't think we want your guy to get bigger, right? We want him to just do a Y jump, not a Z jump, right? But when he walks upstairs between two worlds, two Z layers, that's where things should probably scale. That's just my feeling about it. I don't know. But just looking at how things are going, that kind of is what I feel intuitively like what I want to see happen, if that makes sense. Let me go ahead and change this down a little bit. So that looks about right to me. So if I walk down these stairs to the next level, I mean, that looks like about the amount of parallax that I would probably want from stairwell, from an upper layer and a lower layer, right? I mean, that looks kind of like what I might want to see. So I don't know. We'll have to percolate on it. We'll have to think about it a little bit, but it's starting to get more towards what I actually want to see happen, right? Yeah. So that feels kind of more correct to me. That feels like what I would expect. And so I don't know. It seems to me, it feels like, if I had to guess, what I'm leaning towards saying here is we basically want everything to be about a Z slice, and the Z slices get scaled, but inside a Z slice, things don't generally scale. I mean, if we want like a special effect sometime to make it look like something's coming up towards you or something, we do that. But on the whole, we wouldn't generally have that happen, right? And that seems like a good thing to me. So I'm going to go ahead and say that that's where we'll go tomorrow. I think that's what I'd like to say tomorrow in terms of starting to clean this stuff up further. I'm going to put that in here. So let's see. Is broken up into discrete slices, and the renderer actually understands these slices. And so we're going to say that that's definitely true. And what I'm going to say about that is I'm going to say that, excuse me, Z slices are what control the scaling of things, whereas Z offsets inside a slice are what control Y offsetting, right? And I think that's really going to be the way to make things work with the kind of weird mixed 2D perspective that we expect to have in a game here, right? And we're in a slightly uncharted territory, right? Because most games just don't do this stuff. Like most 2D games just don't have parallax stuff that you can walk between. It's very unusual to have that, right? And so we're kind of in a place where we're having to make sort of an artistic decision about what we want to have there. It doesn't really have anything to do with technology. And that's a little tough. But, you know, I think this is a pretty good compromise. I feel like this would look kind of neat. You know, if you're in a world and you look down and you saw like a, you know, we had like a pit and you could look down into it. I feel like that's going to add a little bit of niceness to the game. And so I think that's what I'd like to go with. And so we'll just assume that we'll do that with the fading, and that'll sort of be how we'll start working on the renderer tomorrow, how we'll start working on something that basically does exactly that levering. So yeah, I think that's good. I'm happy to leave it with that for now, and tomorrow I guess we'll start on that slicing, and we'll put in the fading so that we can kind of fade layers in and out. And we'll maybe try to make that Z slice stuff, maybe we'll try to make that a little more explicit. Like maybe we'll try to force the game to basically say to the renderer, here's Z slices 0, 1, 2, 3, 4 or something, right? Like instead of just passing in arbitrary Z values, so that we can sort of start to think about them discretely, because we're probably going to want to do that for in terms of bucketing things and sorting and stuff as well. All right, so I think we are going to go to the Q&A. Let's do that. There you go. So anyone who wants to ask a question, please put Q: in front of it so I will see it. Yeah, let's do some Q&A. Got probably about 15 minutes left, yeah? Yeah. Ended on time. Pseudonym 73, did I see that correctly that the ground shadow jumps along with the hero? Yes, did you? I don't know, you might have missed yesterday. We turned off that the stuff with the ground shadow jumping along with the hero, because staying on the ground, because we want to do that a different way, basically. It was being done in this really hacked way before that we had just hacked in there, and it still got propagated out to the renderer. And so that's like gone. That's going to be done in the future when we do our shadow stuff. We're going to handle that in the actual game code, was how we decided to do that. Slightly off topic, but can you quickly go over the concept behind move spec? Why not have every entity have their own velocity, drag, etc. values instead? Just for organization? Well, it's not just organization. It's really more just because right now we didn't actually need to put it in the entity, so we hadn't done that yet. So having it as a move spec just allows us to do whichever one we want. So right now they can share those move specs, but in the future we could just move the move spec into the entity if we wanted to have every entity have a unique one, right? And so I suspect actually in the end we probably will have every entity have a unique one, but we haven't really focused on that stuff yet, because that's really more the game code stuff that we're going to do after the engine's done. Is the jump a real mechanic or just for making the system robust? It's not even for making their system robust. It was because somebody asked about it in a stream. Someone had said, can you make the guy jump in a Q&A? So we just threw it in there. It should just be removed. Like we should just get rid of it at this point, because it's not going to be in there eventually. Why don't you pre-compose hero bitmaps into a single bitmap at initialization so there would not be fussing with pushing pieces? Because, well, so we're going to do animation, probably not too long after we get the render stuff working. And we want all of those pieces to move separately. A big part of animation is having the pieces kind of move separately so they get some bounce and they get some feel in there. And so we really don't want them to be baked. That's why I specifically asked Yangshin to draw them as separate composable pieces. And there's a number of other reasons to do that too. But that's the big one, is for the animation. When you are walking up a staircase, will the character suddenly snap back on Y when you transition to the next Z slice? So I don't think so. So I think we'll just move him smoothly up Z like we are now. So that'll be basically his Z slice position. Because all the Z slice positions will be still floating point. They'll be like between 0 and 1, 1 and 2, 2 and 3, right? So when you give your Z position coordinate, it's going to be in terms of slices or something like this, right? We'll figure out exactly how we want to do that in the next few days. If I'm not mistaken, with your way of Z scaling, it's going to be hard to support large in Z structures, such as tall walls that should be aligned across different Z levels. Imagine a multi-story house or so. So I agree with that, because since we don't currently shear things, right, you wouldn't be able to have those things line up. However, I'm not sure how much we care about that, because a multi-story house, you're only seeing the levels at, when they fade in. So I'm not sure how much we care about that as a bug, right? Essentially, there's no way without doing actual 3D mapping to have those things line up and still have things get bigger in the foreground and further in the distance. So we kind of have to make a trade-off. Do we want to do the scaling and break continuous vertical walls so that they don't line up properly or whatever? Or do we just not want to have the scaling? And I think the scaling is going to be a bigger win than the bug is of never being able to make sure that vertical walls will line up, if that makes sense. So that's my hunch. If there are going to be pits, ledges in the game, how are you going to render those? Well, we already are basically rendering those, right? So if there's a pit here, the ground, we turned off the ground buffer, but if there was a ground here, we'd just not render the ground where the pit is. That's it, right? So there's really hardly anything to it. I wonder how the ball would work with the zoom in. So if you want the ball if you want to do the ball zoom, really zooming and the ball don't, I mean, we already had control over however big we wanted the ball to be, right? So the only thing zoom is doing is changing that scale. So you can see what it would look like to scale the ball up just by scaling the ball up, right? Like all you have to do is come in here, turn this guy back on so that we get the ball, right? And if you want the ball bigger, you just say, okay, give us the bigger ball, right? Like so. Oops, that's displacement, not what I wanted. Try that one more time. There we go. So you can make the ball like as big as you want it to be, but it doesn't necessarily, it's not really going to be any different. That might be a little too large, right? And so, the other problem with it too is, remember, it's actually moving the reflection location. So a super large ball also has the problem of outsampling our map for it. So, we've got some other stuff that we have to finish first on the normal mapping code before we can make things arbitrarily large, because we don't really have a plan at the moment for what would happen if you were trying to do reflections for stuff that's outside the map, and we didn't really tune the parameters to make sure that wouldn't happen, et cetera, et cetera. So I'm assuming that it's not quite perfect in that sense, right? But yeah. I will say, that does look kind of strange. I wonder if we still have a bug in there. that we just weren't seeing because we didn't have, I don't remember exactly where we left it, but it definitely looks like the reflection changes in a way that I wouldn't necessarily expect. And I can't remember, that may just be because it's traversing more of the space in Z, right? And so, yeah, so I don't know. And that could also argue for not doing that translation, but I don't know. So yeah, so we'll have to look at that guy more. But really, the zooming has nothing to do with it. It's just the same as when we were changing the size of it before. What games do the bad fade out effect you mentioned? I think the most recent one I remember, or I think this was one that I was playing, was Hatoful Boyfriend. Like, and a lot of those sort of those like visual novel games, for lack of a better term, that's how they do the fade outs. It's really super janky looking. But I was trying to remember. That may not be the one. I apologize to the people who made that if I'm saying it the wrong one, but I think that was the one that I just saw just recently. How will the staircase be scaled when you are moving up and down it? Well, I'm not sure I understand. I mean, it'll get scaled with probably the lower Z slice, would be my guess. And I mean, presumably when we draw the staircase, you'll bake some perspective into it, so the staircase will look, you know, like this kind of a thing. So as the hero moves up it, it's already got that sort of scaling baked in, so it shrinks, but by the time the hero gets to the top, the hero has grown and the staircase has shrunk, so he's the same relative size kind of a thing. So I'm assuming that would just be fine. I don't anticipate any kind of weirdness there, really. Insofar as how could I not know Hatoful Boyfriend? Everyone knows Hatoful Boyfriend. In fact, I just see Garlando Bloom saying at the bottom, everyone knows Hatoful Boyfriend. It is, I have no idea why this happened, and I don't pretend to know anything about it other than for some reason somebody decided to make a Japanese dating sim game where all of the people who you date are pigeons. Like, that's not slang. I mean, they're actual pigeons. They are birds for some reason. I have no idea why. Stellar7, have you heard of Unipop then? I think I've seen it on the Steam like best-selling page for like, I don't really know what, maybe visual novels or something like that. But I've never actually played it, so I don't really know anything about that one. I did play Hatoful Boyfriend. I mean, I played 15 minutes of Hatoful Boyfriend, but I did play. I did like launch the game. Abner, I think this is a wrap because I don't actually see any more questions. So I think that's about it, right? Anyone? No? All right. Well, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. I was a little out of it today, not sure why. Sometimes after coding all day and then Handmade Hero, I don't necessarily have my full coding brain on. It depends on the circumstance. But nonetheless, we kind of did get some stuff straightened out. I think we're getting pretty close to getting our Z stuff kind of where we want it to be. And so I think tomorrow we can go ahead and start trying to work those slices in there. And I feel like what we want to do with that is like start to get the ground buffers working on slices. And then, so that we can kind of have ledges that look down into lower things and see those kind of clearly. And then also start to use that to do sort of that reflection mapping picking properly. So we know that like, okay, this ground is the ground buffer that we use for, doing the reflection mapping or that kind of stuff, right? So I think we pretty much know what it is we got to do here. We've got a couple more days of getting everything lined up properly, but we're in pretty good shape. So hopefully you'll come back tomorrow and join us for that when we go ahead and start the implementation of getting those slices kind of formalized and working properly. It'll be same time, same place tomorrow, 5 p.m. Right here on Twitch. If you would like to follow along at home with the source code, you can do so by pre-ordering the game. It comes with the source code and you can download it every night. I upload it after I finish coding. We also have a Patreon page if you want to support the video series. That's an easy way to do that. There's also a forum site that has annotated episode guide and place to ask questions and ports to Mac and Linux, good stuff like that. And finally, there's a tweet bot that tweets the schedule at you. So if you want to know when the stream's going to be live, sometimes we change the times and sometimes there's days off or stuff like that. That's the best thing to do is just subscribe to that tweet bot because it'll always tell you. And you can always go to its page if you want to check it out. So that's about it. I hope everyone has a good evening and I will see you guys back here tomorrow for some more Handmade Hero. Take it easy, everyone.